live. Okay, so here we are. So these are all of the different translations or transformations of functions we're going to do. Okay, this is a vertical shift, a horizontal shift, or it's the opposite. A vertical stretch, if there's a number on front, or shrink. This is going to be a horizontal stretch or shrink. This is a reflection over the y-axis, and this is a reflection over the x-axis. And here you go, Sydney.
Okay. I'm going to be famous.
Yes. So let's take a look at 2.6. We've done this. In fact, it's really nice because this morning I was talking to Mr. Massey, and he said the one thing he needs you guys to know is one is completing the square, which we'll get good at, but the other, he said, make sure they can do translations. I go, well, we've done it. We've already done a lot of this, haven't we? Right? So today, 9, 11, 19. Okay, topic is translations or transformations of functions. Okay. Okay. So first of all, x squared. I'm going to do that. I'm going to put that down on my graph. I'll wait for you. So we know what the x squared graph looks like, hopefully. Yep, it's a parabola, 0, 0, 1, 1, 2, 1, 2, 3, 4, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. And we know it's symmetrical because it's x squared. And there you got it, okay? How am I doing? So, question number 1. If f of x is my parabola, then this is a question. What are we going to do? If this is my f of x, A says what?
To shrink it.
Bring it down.
Shift it down -4.
Right. Yeah, bring it down 4, right? Everybody agree? Just shift it down 4. So we're going to take my function and go 1, 2, 3, 4, and I'll put my parabola. I'm not going to change its shape at all. I'm not changing the shape. It's not a transformation. It's just a translation. I just moved the entire graph down 4. That's it. Okay. B. What are we going to do?
It's reflected.
Okay, reflect.
And then you shrink it times 2.
Yep. Over x-axis, and we're going to make it twice as tall.
Yes.
That makes sense? Twice as tall. But when we say tall, it's going down, right? So we're going to twice as tall. So it's going to look like this. So instead of my 1, 1, I'm going to go twice as tall. 1, 2. You okay with that? Go over 1. 1 squared is 1, but twice as tall. If I go over 2,
8?
yes. 2 squared is 4, but twice as tall. So 1, 2, 3, 4, 5, 6, 7, 8, and 3 is going to be off my page, right? So beg that. It is symmetrical, right? Okay, how's that? Okay. How about C? Am I going too fast?
Horizontal shift.
Horizontal shift, yes. Which way?
To the right.
To the right, yes. So right 3 units, right? So take my parabola, just going to move it right. 1, 2, 3, and just move it, the vertex over, and just put it in, right? Same thing, 1, 1, 2, 1, 2, 3, 4, 3, 4, 5, 6, 7, 8, 9, and of course it's symmetrical. And you don't have to put the line of symmetry in, but I'm going to, just because it's easier to see if I put the line of symmetry in it, because you can see it reflects, not over that, doesn't reflect over the y-axis, but it reflects over the line of symmetry, which is right there, 3.
Can we just go 2 and not the third one?
You can, that's fine. I'm going to do them all just because that's me, Zoe. Right? I'm an overachiever, okay?
Yeah.
All right. Now, D. Okay, D. This is the tricky one. Does not make it twice as tall. It's on the inside. It makes it twice as wide. It makes it fat. So let's see how that works, okay? So we're going to do a horizontal stretch. Okay? So 0, 0. Okay? So if I go over 1, I'm not going to go, I'm going to go twice as far. I'm going to go over 1 and up 1. Okay, I'll do it again. So instead of going over 1, I'm going to go actually twice, and then it's 1, right? Now I'm going to go over what? 2, but I'm not going to go 2, but I'm going to go 4, twice as wide. Now, bear with me, because think about this. Think about this. You're going to plug in, teach them. You plug in 1, you plug in 2, plug in 3, plug in 4. So if I plug in 1, I'm really going to have a 2. If I plug in 2, I'm really going to be going to 4. If I plug in 3, I'm really going to 6, because you plug it in, okay? So I'm going to go to 4, and then normally 2 squared is 4, so I'm going to go up 4. I'm going to go 1, 2, 3, 4, okay? And I'm going to do the same thing on the other side. 1, 2, 3, 4. Now if I look at it, it's 2 things. It's a horizontal stretch, and it's a vertical shrink. Because if I look at it, it's half as tall. See, it's half as tall, or it's twice as wide. Okay. So, let's move on. F. So the first thing I would do is figure out where it's going to be. So the vertex, I'm going to put the vertex at -3, -5. You okay with that? I'm going to go to -3, -5. Okay. And then I'm going to go and do half as tall. So if I go over 1, I'd normally go up 1, but I'm going to go half as tall. So 1, 1, I'm going to go 1, 1 half. Half as tall. Okay. And if I go over 2, I'd normally go up 4, but I'm going to go up half as tall. If I go to 3, I'd go to 9, but I'm going to go half as tall. Half of 9 is 4 and a half. 1, 2, 3, 4 and a half. And it's just symmetrical, so I'll put the other points in here like this. Like that, okay?
They don't fit.
No, they don't fit. My graphs aren't very good, okay? All right, now, I am going to stop there, and we'll talk about this tomorrow, because we're going to run out of time, okay? So let me pause. Oh, yeah.